roots, demonstration of cubes and cube roots, and then fifth roots. And then I thought I would say a few words about the program. Okay, moving on. For the first part of the agenda, what I'm going to do is audience will have to. Before we do that, I've got some scientific calculators here, which I want to sort of hand out to everybody. Okay, and Lisa, thank you very much. I mean, hand it out at random to folks in the audience, and maybe we'll have somebody from the audience come up and give Ganesh a 2-digit number, so that I can start reciting the multiplication tables, and you'll see the answers on the spreadsheet, and I won't be looking at them, I promise. Okay. Okay, maybe why don't we have a volunteer come up here and right next to Ganesh and provide a 2-digit number, and Ganesh maybe you can switch to spreadsheet mode. And if you look at if you actually see, what Ganesh will do is, we'll enter a number, once the audience presents a number, we'll enter that number and you'll see the multiplication table of that number from 1 to 10. So what I'm going to attempt to do is actually not look at the spreadsheet, of course, and actually as soon as the number is provided to me, I'm going to attempt to start reciting. So if somebody could come over from, I need a volunteer who could come over and give Ganesh a number, a 2-digit number. 57, 114, 171, 228, 285, 342, 399, 456, 513, 570. Let's try one more example, one more number. 89, 178, 267, 356, 445, 534, 623, 712, 801, 890. Thank you very much. For the next part, I'm going to do, maybe we'll switch to PowerPoint. We'll move on to squares and square roots. Just a slide up there to, most of you know what squares and square roots are, and your children who are going to obviously know them. But just to reiterate, a square is basically square of a number is the number multiplied by itself. So it's obvious 4 square is 4 times 4, which is equal to 16. And square root of it is just the reverse of it, sort of. So the square root of 16 is 4. So what I'm going to attempt to do is, again, we'll have a volunteer. We'll do like 2 or maybe 4 examples here. We'll have one volunteer come in and give me like a 2-digit number. And Ganesh is going to project that on the screen. And maybe we can even have, like, I'll try and raise Ganesh to the spreadsheet calculation if possible. So a volunteer can come along and give a 2-digit number, and I'll square the number. One more. One more.
185.
7225. 85 is 7225. Yeah, maybe shout it out then. 97 is 9409. 55 is 3025. Any more? 79 is 6241. Okay. Alright. So moving on to so that was the squares part, and then now I'll try to, this is a slightly tricky problem. Oh, did we actually do, oh, okay. Before I move on to doing squares, I wanted to point out a concept. You guys know this, but just to reiterate, there's something called a perfect square, and anything that's not a perfect square is a non-perfect square. A non-perfect square is a loose term. I mean, something to define to just about define anything that's not a perfect square. So what's a perfect square? In this case, perfect square versus a perfect square. So a perfect square is basically something that has a rational square root. So what does it mean, a rational number? Rational number means it can be an integer or it can be expressed as a fraction. Basically, it has an end. Okay? Non-perfect square is something that has an irrational square root. So, which means it's like a decimal number that will go on and you won't see the end of it. So just to give you an example, 16 is a perfect square because everybody knows the square root of 16 is 4. While 17 is not a perfect square because it doesn't have a perfect square root. It's an irrational number. The actual value is like 4.123 and it goes on and on and on. Just like root 2, square root of 2 is not a perfect square. So 2 is not a perfect square. So just wanted to illustrate this concept because the next part of the show, what I'm going to attempt to do is to actually compute the square root of a perfect square and then after that compute the square root of a non-perfect square. Okay, moving to the, actually we'll move to the slide, sorry. Okay, what we want to do in this section, there's a little bit of audience involvement. Audience needs to actually pick up a 2-digit number and then they need to actually use the calculator. So one of you guys who has those calculators, if you can please come up and tell that to the next. You need to actually square the number yourself. You need to use the x squared function on your calculator. And you need to tell me the result. Because we are doing perfect squares now. And once you tell me the result, I will actually attempt to calculate the square root of that result. So that will be that will be necessarily a perfect square. We'll have a perfect square. So we'll do an example with a couple of examples with 2-digit numbers and a couple with 3-digit numbers. All right. So moving on to the spreadsheet. So if somebody can come in with one of those guys, well, any of you who's got the calculator with you, if you can come down and do this exercise, pick a 2-digit number. Thank you very much, sir. Thank you. $52. Thank you. Maybe try another number. 76. Thank you. Thank you. Anything else?
4761.
69. Thank you. 78. Sorry, 78. Yeah. 7921. 89. Okay. Any more? 9025 is not a perfect square. I believe 9025 is what you might have intended. It's 95. Okay. All right. So maybe we'll move on to a 3-digit number now. So I'll probably use the whiteboard, and I'm going to be slow with the 3-digit number, okay? Because the computation and the intensity of computation really increases. Okay. So I do need the whiteboard sometimes simply because if you pick a 3-digit number and square it, it'll either be a 5-digit or a 6-digit number, and sometimes I can't keep all the digits in mind, especially if I'm doing other things. Basically, I can multitask, and I'm pretty single-dimensional when it comes to that. So maybe we can have somebody step up and give me a 3-digit number, square it, just like what you did with the 4-digit number. And you have to excuse me that I will be a little slow with the 3-digit operation. 14641. The answer will be 121, sir.
119025.
Okay, sorry. What was that? 119025 is what you said? The answer will be 345.
732 736.
732 736. You will have to give me some time. It is 856. Was that right?
Yes.
Yeah, some of the bigger numbers get a little challenging. Okay? All right. Anything else?
One more.
One more? 998001. Done being 999. Thank you. Okay, now what we'll do is I'll take up, now the next item will be a little bit more challenging because, going back, extracting the square root of a perfect square was relatively straightforward. I mean, it was challenging nonetheless, but it was still, it's got a perfect square root, you can sort of estimate it if you know some principles of mathematics and so on. But the tricky part is if you give somebody a non-perfect square, how do you estimate its square root? Like if you take, if I tell you the square, what is the square root of 25? You'll come up with the answer immediately, it's 5. But if I tell you what is the square root of 26, that becomes a little bit tricky, right? Because you need to really get into it. It doesn't have a perfect square root. You need to estimate. You need to backtrack, and so on. So unfortunately, I'm going to be a little bit slow at this task. So maybe I'm going to try and attempt. So I hope you'll excuse me if I'm slow. But this is for the audience. This task is relatively easy to present. You'll have to give me first we'll try with a randomly chosen 3 or 4 digit number, so anybody can feel free to shout it out. And Ganesh will actually put those on the spreadsheet. I will look at the number and I'll try to figure out how to compute its square root. Okay, so let me erase this part. Okay. All right. Sorry about that, it's just taking me a while to erase it. Okay. Alright, so let me see if so want to try a 3 or 4 digit number, and Ganesh will actually also be typing that number and he'll be projecting the answer.
393.
393. Ganesh, you got this? Okay. 393 will be and again, sorry about that, it's going to take me some time. It'll be 19.63. I'm sorry, it is, I take that back. It'll be 19.81. What is the answer?
19.82.
82.
Yes, sorry. All right. Anything else? Maybe 3 digit, 4 digit? The number is 4321. Okay.
It
is 65.75. 70. Thank you. Okay. Yeah, as you can see, trying to get the square root of a non-perfect square is more challenging. So can we try maybe a 5 digit or a 6 digit number? Because its square root will be in 3 digits and plus the decimals, of course. Anybody? 5 digit, 6 digit? 13167. Okay. It is 114.52. 72, sorry.
74.
Okay. This gets harder. So, getting the 5th significant digit is sort of hard. And anything else?
183. 737.
Okay, the number is 183. 7?
43737.
Sorry, could you repeat that?
443.
43.
737. 43737.
43737. Okay. It is 209.1. Alright, so moving on, let's, I guess we are done with squares and square roots now. My next item on the agenda was cube roots, cubes and cube roots. And just to reiterate, you guys know what cubes and cube roots are. Cube is the same number, just like squares, you take a number, but this time you actually multiply it by itself 3 times. So 4, if you take 4 times 4 times 4, it is actually 64. And likewise, the cube root of 64 is 4. Okay? So it's very obvious what cubes and cube roots are. So moving on. What I'm going to try and do is actually do a cube first. I'm going to cube the number. So you'll basically give me like a 2-digit number. I'm going to try and attempt to cube it. Okay? And I think I'm going to use the whiteboard here because I think once you start giving me these big 2-digit numbers, the cube actually is like 66. Okay. You want to take a shot? Cube? 39. Sorry, can you... 39 you said? Yeah. 39 is 59319? Yeah. Next one? 76. Huh? 76. 76 cube is 438976. Next one, sorry? 67. 67 is 300763. Anything else? Sorry, I couldn't hear you. 88? 88 cube. This one is interesting. Is it 681572? 472. Sorry, mistake. Okay. One more, or do you want to? We can move on. 93, right? 93 cube is 804357. Okay? Alright? Okay, then I guess we'll now move on to cube roots. Again, I want to highlight the difference between a perfect cube and a non-perfect cube. Perfect cube, just like a perfect square, has a distinct rational cube root, while a non-perfect cube has an irrational cube root. The same thing, like you'll have cube root of 64, it's 4. I mean, it's a lot of people know that, it's very obvious, you can calculate it quickly. While the cube root of 65 is not, it doesn't end in 4, like it's a never-ending decimal, it's an irrational number. In this case, it's 4.0207. So, first I'm going to try and attempt a perfect cube. So what the audience will have to do is the following. So you'll have to, just like what you did with the square, somebody will have to come over, they'll have to pick a 2-digit number. Then once you pick the 2-digit number, you'll have to cube it on your calculator, give it to Ganesh, and Ganesh will give me the answer, and Ganesh will give me the final cube, and I will try to calculate the cube root of the number. Since these numbers get big, I'm going to use a whiteboard to actually write them down. Okay? Okay, so anybody monitoring with the calculator, maybe come on over and or give the number to Ganesh or shout it out. Or
132651.
Yes, 132651 is the number. The cube root of this number is 51.
Good.
Another one? 140608. The cube root of this number is 52. 54321. Are you sure this is a perfect cube? No, it's not. Okay, we'll do that as next part of the exercise. But I'll get you the problem. I'll compute it. But this is just going to be perfect cube. 91125. The cube root is 45. Anything else? 753571. The cube root will be 91. Okay? Now let's try a 3-digit number. It's going to take me time. So so these numbers can become 9 digits. So I really need to write them down. So give Ganesh or give myself a 3-digit number. Take a 3-digit number, cube it, give me the answer, and I'll try to get the cube root. 96071 912. And again, I'm going to be very slow with this, but I'll because obviously this is what 8 digits, and it's going to take me some time. Is it 458? Yes. Okay. One more 3-digit. 1860867. Could you repeat that, please? 1860867. Can you come over? I'm sorry, I couldn't hear you very well.
1860867.
1860867. Okay. Yeah, this is going to take me some 1860 8867. I'm sorry about that. I'm blanking out a little bit, but I will. Is it 103? 123? I'm so sorry. I'm sorry. I messed up somewhere. Sorry. Okay. Let's try one more.
776.
Yeah.
776.
Yeah.
151.
151.
559.
776 151 559. Nine 119. I'm sorry I messed up on the first one. It was actually simpler. I don't know why suddenly I messed it up. Okay. Okay, moving on. Alright. Moving on to the next one. Now I move on to a slightly more challenging problem. It is actually, now these cube roots of perfect cubes, right? If you know some principles of mathematics, you can actually start estimating them to some extent, because you can know that if a cube ends in 8, its cube root ends in 2. So you got some idea of where you're going. So you can get the first 2 digits by knowing some cubes, estimating them. You don't have to do all the calculations. You don't have to go all the way. So it's a little bit easier problem to estimate. Now I'm actually going to try a much harder problem where the cube root there's no perfect cube root. So like 64 has a cube root of 4, but 65 is all decimals. This is going to be a harder problem, so I'm going to restrict myself to 3-4 digits or 5-6 digits. Because the numbers go bigger, it becomes difficult, and this is much harder compared to just extracting that of a perfect cube. So what the audience will do is you'll just provide me with let's start with a 3 or 4 digit number, and then we'll move on to a 5 or 6 digit number. I'll try to estimate the cube root of that number.
Oh, it's already done.
उसने किया अभी. There was the biggest number set.
So shall we try? Any 3-digit, 4-digit?
Cube, right?
1863.
1863 is the
Number.
number given to me. So give me so I'm just going to try and estimate this. It is 12.35.
0.
Okay. Any other number? 529. Cube root of 529. Okay. Cube root of 529. It is 8.091 or 8.092 maybe. 8.091? All right. Maybe one 6-digit number and then we'll move on to fifth root. I think we are running a little short on time. Sorry, can somebody... I can hear you. You can come forward a little bit. 158765. The cube root of 158765. It is 54.14. Sorry, what was the answer? Correct, okay. Alright, then let's move on. I got only one more item in my agenda. Okay, alright. I've got only one more item in the agenda. Where the board is, I don't know where Sorry, yeah, oh, I have it in my hand, I didn't. Okay, we're moving on. We are going to do a fifth root. The fifth power of 2 is 32. So 2 to take the same number multiplied 5 times. So the fifth root of 32 is 2. Okay. So actually going back to the PowerPoint. So I actually wanted to do the fifth root of a perfect fifth power and the fifth root of a non-perfect fifth power. I'm going to skip the fifth root of a perfect fifth power because that's a simpler problem. I'm just going to take on, because we are running short of time, I'm directly going to take on the most challenging problem out there in today's, in my, for my demo today. I'm going to take on the fifth root of like, give me a 6 to 10 digit number and we'll do the fifth root. It's a random number, it's not a perfect fifth power. And as I said, just like square roots and cube roots, trying to get the fifth root of perfect fifth powers is much simpler compared to trying to get the fifth root of a non-perfect fifth power. So, if you can give me like a 6 to 10 digit number, I'll try to extract its fifth root. Okay, somebody wants to try? Somebody who has the fifth root of a
981485.
981
1485.
981485 is the number.
It's just a number. कोई और बोल नहीं रहा.
It is, I believe, 15.84. What is the answer?
15.78.
Okay, that's a little off. Sorry. One more try. One last try. One last one. 371 371,290 is the number given to me, and the answer for that is, I believe it is 12.998.